It's Stereo Police, back with another video, and this one will probably have a somewhat limited audience based on the subject matter that I'll explain in a minute. And what you're looking at here has nothing to do with the video. This is my A-1000, one of my favorite amps, and it's on the bench because I'd like to figure out a way to get a better power cord than this tiny narrow gauge zip cord, lamp cord thing that they used. I guess this is this is factory. Perhaps it doesn't appear that it's ever been tampered with or changed, so I'd like to upgrade the power cord and get something a little more substantial. Now I'm on a tangent now already. I haven't even started my video, but I'd like to get, you know, something like this. A little more substantial in there to handle the current draw. So that's why it's on the bench, but that has nothing to do with what I'm going to talk about today. What I'm going to talk about today is really, in essence, an answer to questions that I've received about the Yamaha A-S1000, which I still have. It's dark in here. There she is. I still have hooked up into my main system with the Klipsch. Still loving it. A great amplifier. And let me go ahead and get this on the tripod and start the video. But I received a lot of questions. Maybe I'll do this without even cutting. There we go. Okay. I received a lot of questions. Let me get a little closer. About the differences between the various Yamaha amplifiers in the family of the AS1100. You know, what are the differences, and what justifies the differences in price? And I kind of answered that question a little bit here and there on in response to comments on various videos that I've posted regarding the AS1100, but I never really looked into it ultra thoroughly. And I was kind of curious myself. Let me backtrack a little bit to say that in the family of amplifiers that are all similar to the AS1100, and here's the AS1100, that's my guy. We have the AS1000, 2000, 1100, 2100, and 3000. And as you can see, there's a substantial difference in price. The Yamaha suggested retail price for my 1100 was $2,500. I rounded these up to the nearest 100. You know, it was like $24.99, $98, some ridiculous amounts. $2,500. And going down, we've got the AS2000 at $500 less, and then a couple $100 less than that is the AS1000. Now, moving up from the 1100, we have to go up. We have to bump up one more $1,000 to get the AS2100, and then boom, there's a colossal jump here to the AS3000 at $7,000. You know, twice the price. So, you know, if one were interested in purchasing one of these amps in the family, and by the way, the family of amps I'm referring to all have the floating balanced output topology, which is basically a circlotron amplifier. A really cool way of, you know, it's fundamentally different than your standard single-ended transistor amps or your standard push-pull, whether Class A or Class AB. Fundamentally different operating principle. Now, nevertheless, this circlotron floating balanced amp does operate in Class AB, but the way it does things is fundamentally different, and I kind of covered that in previous videos. I won't get into it now, but the point being, the family of amplifiers that has this floating balanced amp are these guys here. Yamaha makes some amps down here in the sub $1,000 range that are those amps are standard class A, B, push pull, complementary pair, you know, ancient standard technology. Those I'm not even going to consider. I haven't heard them, maybe they're good, but I'm not even going to consider. So I'm considering this family of amps right here. And within this family, I've received quite a few questions about, you know, what are the differences? What am I getting for my money? And when I started to look into it, I intended to only make about a 5-minute video. And just like everything else I do, it mushrooms and escalates, and I start doing more research and getting into it, and more questions are raised than I have answers to, and before you know it, I studied these things, I pulled every schematic, and before you know it, I'm like 4 hours into this, and I've come up with just a comprehensive answer to the question. Probably way too much information for the average person, but I never shy away from way too much information. So that's what I'm going to cover today. So if you've ever wanted to know the differences between these amps, I'm going to tell you. Now, I'm going to not a spoiler, but I'm going to give you my I'm going to give you my summary right now in case you just don't even care to listen to the next umpteen minutes of this, or hours, or whatever it's going to be. I'm going to tell you that let me see here. My printer spit out white paper. I'll give you the conclusion now, which I don't seem to have. Well, I need to go back to my printer. Okay. Well, I'm missing something. But anyway, the conclusion is the AS1100 is the best value of all these amps. The second best value is the 2100. These guys here, the AS1000 and AS2000, are just simply out of the question, and there's a reason for that I'll answer as I go on. I wouldn't even buy either one of these things. And I'll answer that question as we go on. I don't consider them, based on the schematics that I studied, I don't consider them to be up to standards of true hi-fi. And well, I'll tell you why. Because they have an op amp in the signal path. I don't care what Yamaha says on their website about being fully discrete. Most of the circuitry is discrete, but there's an op amp in the signal path that you cannot bypass or get rid of. So ultimately, when you're listening to this amp, you're listening to a 10-cent item, operational amplifier in the signal path, and you cannot get rid of it. Whereas the rest of these three right here, the 1100, 2100, and 3000, are all fully discrete, awesome designs through and through, with no op amps in the signal path, unless you use the tone controls and it kicks one in. But with the tone controls in neutral, the op amp is relay bypassed out of the signal path. Okay, so 1000, 2000, out of the question. I wouldn't consider them. But I'm going to go over the differences. I'm going to tell you everything, in case you are considering them. I wouldn't. These three right here, the 1100 is the best value. The 2100, the AS3000, of course, is the ultimate. It's got it all. And I'll explain that as we go forward here. But it is ridiculously overpriced in comparison for what you get with the 1100. Or even the 2100. Way, way overpriced for the differences. Because in essence, the amplifier circuitry, okay, if you're not using balance, if you're using single-ended standard RCA inputs, the amplifier circuitry between the 1100, the 2100, and the 3000 is extraordinarily similar. Almost identical. But I'll explain to you what you do get for that 7000 as we move on here. Okay, so there you go. You don't have to watch the video now. But if you're really curious, and you want to get into the nitty-gritty details, I've got that for you here. All right. So anyway, let me hit pause here, and we'll get started with the first part of this. All right. So let's start out with the basics. Let's look at the front panel. And by the way, I printed all this stuff out from the service manuals of each of these amplifiers. Let's start out with the front cover, the front panel. All right, so your AS1000, and I'm going to always start with the cheapest and move towards the most expensive. Your AS1000, you got your standard bass, treble, balance. Got a couple of inputs, and your speaker selector A and B, your power, and you have a mute button. This is a motorized volume control, and your mute button actually turns the volume down physically. I think that's the case with all of them. But all right, so your 2000 gains a trim switch for your headphones, so you can trim the level of the headphones from I can't even read that, negative something to +6 to +12 dB. So it's basically it'll adjust it because different headphones have different sensitivities. I don't listen to headphones, so I can't speak much to that. You also get a moving magnet moving coil switch on the front, and you do get one pair of balanced inputs. So if you're really into balanced line inputs, and you get one, and that's the big change on the front panel there. Okay, so let's move up to the 1100, which is mine. Okay, of course, boom, for the first time you get these beautiful glowing LED backlit VU meters, and you get a VU meter control so that the meters can either bounce around to the peaks of the music, or they can be VU meters that basically measure a wattage into an 8-ohm speaker. Moving up to the 2100, from the 1100 you gain a balanced input, and you get back your trim for your headphone jack. And of course, moving up to the big boy, the 3000, you get extra large, more than twice the size VU meters. I'd love to have that. I love VU meters. You still get your trim for your pot, and you get two balanced inputs. You get two of them. Two pair for different sources. Okay, that's the difference between the front panel. So let's take a brief look at the rear panels of these things. See, I told you this was going to be thorough. And I got really interested in this because I got to think, well, maybe I really want the 2100. I can't afford the 3000, that's just ridiculous. But maybe I want the 2100. I kind of still do, maybe. Okay, so rear panel. I'm only going to point out the major differences. Okay, so there's your 1000. A little bit blurry probably. There's your 1000, and so what do we get? Well, with the 2000, of course, we get our balanced inputs. There they are. We get one pair. Nothing else substantially different. When we move up to the 1100, we go back to having no balanced inputs, but we do get a auto power on switch that will sense a signal and turn itself on and turn itself off without a signal if you don't want your amp to stay on for long periods of time when you're not listening. And you get some triggering stuff that I have no idea what it is or how to use it. I've never used it before, but there's some kind of triggering between external amplifiers and external devices that you can control there, and quite frankly I don't know what it is and I don't care. As we move up to the 2100, well, we get back to our having one pair of balanced inputs, and we maintain our triggering stuff and our auto power on standby thing. And when we get to the big boy, the 3000, there's our two pairs of balanced inputs. And along with our balanced inputs, we get some ability to attenuate, and we get some ability to alter the phase. If you really want to toy around with the signal path. I don't have balanced inputs. I've never had them. I've never used them. I'm not opposed to them, but I don't know much about them. And I can't speak to something that I don't know much about. But if I had this amp, I would use the balanced lines because my DAC outputs a balanced signal, and I would go ahead and use them, but I'm not sure it would make much of a difference in sound. Okay. All right. So, just in summary, for the first part of this is, and we're going to get into much more detail than this right here. We're going to move on to some internal and some design considerations. But the first part of this is, we get, as we move from the least expensive to most expensive, we we gain some VU meters with the 1100 and the 2100, and some larger VU meters with the 3000. The ability to trim your headphone, well, you don't get that in the 1000, you get it in the 2, you don't get it in the 1100, but you get it in the 2100 and 3000. Balanced inputs, you only get that in the 2000. The 2100 you get one, and the 3000 you get two of them. And with the 1100 on up, you get auto power standby. And I believe I don't use it because when I turn my amp on, I want to leave it on until I turn it off. Sometimes I want it to warm up for an hour or two before I listen. I don't want it turning off. But I believe I know it'll automatically turn your amp off after a certain period of time if it doesn't sense a signal. And I believe when it senses a signal, it'll automatically turn it back on. Don't quote me on that, but I think it will. All right. So there we are with some of the minutia. Now let's get into make sure I line this up with the camera here. The power transformers. We're going to cover all aspects of the circuitry. I'm going to go one by one in no particular order. But these are things I consider to be significant to the design, operation, function, and sound of an amplifier. So I'm going to cover various components and various circuitry elements, from the power transformers to the filter capacitors to the type of transistors they use. And I'll tell you what you get for the money. And in essence, as far as the power transformer goes, which is a very critical, integral part of any power amplifier, with the AS1000 all the way up through the 2100, you get a standard iron core transformer. And I just printed out a picture from the Yamaha website. It's a nice looking one. I'm sure it's high quality. It'll do the job. I have no issues with it. However, what do you get for that? Or what are one of the things you get for that extra twice the price for the AS3000 at $7,000? What do you get? Well, one of the things you get is a toroidal transformer. And these transformers are notably more expensive to manufacture. They're more expensive. They do produce far less noise based on their nature than an iron core transformer, and they're alleged to have the ability to supply current, I think a lower resistance or something, to supply current on demand quicker than an iron core. I've read things like that. I never really delved into why that would be. And there's probably some other, but I believe less noise. They contain, based on the winding nature of it, they're able to contain the noise they generate a lot better than an iron core. That's the big one. And they're far more expensive, but not nearly that much more expensive to come close to justifying a leap from $3,500 to $7,000. Now, let's take a look at the output transistors. One of the critical parts of any power amplifier are the final transistors, the power transistors that your signal sees or passes through before before traveling to your speakers. And there are major fundamental differences here between these amplifiers. In summary, the AS1000, you get, now again, the topology of these amplifiers is similar. The output stage is this floating balanced circlotron design. That remains the same. But the 1000 uses paralleled, a total of 6 parallel, three per side of the balanced output, bipolar junction transistors, 2SE4468s. And this is the output power amplifier stage. Okay, this is the circlotron configuration. I won't get into detail about this, but here are the 3 paralleled, fully paralleled, what did I say they were? 2SC4468s, bipolar junction transistors. They're not MOSFETs. And I just did a quick search on eBay. I'm sure prices vary, but I found one for $9, $10 a pair. Okay, reasonably expensive for transistors, but fairly cheap. All right. Now, when we jump up to the AS2000, okay, we maintain a similar, the same output topography, the floating balance, but we change the transistors to the BJTs to C6011s. Okay, so here's the same paralleled 3 per side C6011s. And I don't know what the difference is between the two, why would they even change between the two, but they're roughly the same. It's $5.99 a pair I found on eBay. It's not anything, I mean, perhaps these sync a little bit more current, and I don't know. Why would they change the output transistor between these two amps when the amps are damn near the same price? It just would seem to be better to keep them the same for manufacturing purposes, but they're still BJTs, bipolar junctions. Now, as soon as we jump up to the AS1100, 2100, and 3000, we get the exact same power output transistors, and we make a huge jump up to some awesome MOSFETs. And this is a depiction of the AS1100's output stage. I know it's small, no need to get into it, but in detail. But here are the end. There's only 1 per side, because these things are monsters. They can handle all the current that's necessary to produce the power that these amps provide all by themselves. They don't need to be paralleled in 3s. That's why the others were paralleled in 3s, because they're wimpy transistors. You could look at it this way: it takes 3 guys to lift the load, whereas this one guy can lift the load by himself. 3 times as strong. And they're MOSFETs, and MOSFETs, without getting into detail, are the solid state equivalent to a vacuum tube in terms of how they operate, in terms of their transfer function, so to speak. Well, I won't get into MOSFETs, but I love MOSFETs, and we've got them right here. And just a quick search of eBay, and I'm sure these prices vary in different sources, but these things were substantially more expensive. I found these for $57 a pair. That's a lot of money. Okay, not to say that I'm equating price to quality, but these things are more complex devices to manufacture, and they handle a hell of a lot more current and can dissipate more power than those wimpy BJTs. So there we have it. You get the exact same, pretty much the same output amplifier topography and transistors. All these transistors are the same in the AS1100, 2100, and 3000. Getting the same. No difference. There's the 2100 if you want to compare. It's the same. And here's the 3000. It's the same. No difference. I wasn't able to spot a difference between any the driver transistors, the power outputs, or any of these bias regulating transistors in here. All the same. So why would I want to spend that $7,000 when I can get the same for $2,500? That'll be a common question to ask yourself. All right, let's move on to, just for comparison, directly from the service manuals and probably from the website. Also, what are the differences between power ratings of all these amplifiers? Well, you know, look, the AS1000, 90 watts into 8 ohms, 90 watts into 8, 90 watts into 8, 9. It goes up to 100 watts into 8. The AS, move that over. When we get up into the AS3000 range, but the only reason is not because the output circuitry is any different. I'm sure it's because the transformer. The toroidal transformer probably produces a little bit more voltage. Perhaps the rail voltage is a little higher. I should have looked at that. I don't know if the rail voltages are higher, but look, between 90 and 100 is not that significant whatsoever. It's considered to be effectively the same, really. Okay. Now, let's look at the main capacitors. These are those large, move this over here, the biggest capacitors you see when you look inside that amplifier. There's a bank of 4 of them. And those are the main storage / filter capacitors for the output transistors, or for the output stage power supply. And they are also extremely important to the circuitry. But guess what? They are exactly the same in every one of these models. They are 3,300 microfarads, 100 volt. I don't know why this says 200. You know what? I was copying in Excel and it copied something over, but they're all 100 volt. My apologies. Okay, they're all 3,300 microfarads. And just if you want to see for yourself, here is, well, actually you can't see for yourself because what I did is I went to that portion of the schematic and I found the power supply portion that feeds the outputs, and found the capacitors, and there they are right there. And this portion of the schematic is identical in all the amplifiers. Doesn't change. And I checked all of them, and they're all 3,300 microfarads, 100 volt. So no difference in your main filter storage capacitors. Okay, now here's where we get into some differences, and I'm going to talk about this category called discrete signal path, meaning the signal path from the input, and let's say you're using the CD inputs or the line 1 inputs all the way through the output, is built out of discretely designed components, transistors, resistors, capacitors, etc. Discrete components versus integrated circuits such as operational amplifiers. Op amps are horrible. They have no place in the signal path of any high fidelity component, or amplifier I should say, in my opinion. Amplifier. I realize they're used all over the place in DACs, and in many other components, but I'd rather know that the folks designing the amplifier that I'm listening to are skilled enough or cared enough to not utilize a 5-cent component in the signal path to do any sort of amplification whatsoever. In my opinion, high-end means carefully chosen components, whether they're transistors, capacitors, resistors, quality components with a discrete design that you can control every aspect of, instead of an integrated circuit with an entire amplifier on it, which is what an op amp is. Alright, so let me give you the summary first, and I'll go through some slides here. So for the AS1000 and AS2000, there is in the signal path there are op amps used in the tone control section, and the signals pass through that section regardless of whether the tone controls are in neutral. And in both of these, the 1000 and 2000, even when the tone controls are in neutral, the signal still goes through the op amp in its flattened mode. It's still going through the op amp. The op amp is still amplifying that signal, though it's not affecting the frequency response, hence the tone. Whereas in the AS1100, 2100, and 3000, when you place those tone controls in the neutral position, you actually hear a click, and that's a relay. And when it's in neutral, those op amps are fully 100% bypassed. The signal never goes through them. That's the way to go. And that's one of the reasons I would not even consider the 1000 or the 2000. Quite frankly, look at that. You get the 2000, okay, yeah, it has a balanced input, but for $500 more, forget about it. 1100 is a bargain. So, on that same topic, hold on a second. Here is the from the block diagram of the owner's of the service manual. This is pretty accurate. This is a block diagram of the tone control circuit where you have an input signal coming in, and there are really 3 op amps there. And when you're adjusting the tone controls, you're affecting you're using these op amps as filters basically. But even when you're in the neutral position, flat, the signal still has to go through these op amps. There is no fully bypassed way around them. Signal is always going through them. Okay, that's the 1000 and 2000. However, oh, and this is a depiction of the 1000, 2000. Okay, here are the actual op amps from the schematic, and this is the signal path right here. And there's no, I looked everywhere, and there's no bypass around these things. The signal always goes through them. Whereas, here's the block diagram for the 1100, 2100, 3000, and you will see this depiction right here, where on the flat condition, okay, these op amps are fully bypassed. Signal does not go through them. This is a relay internally. You hear it clicking. So the signal never passes through those evil, horrendous, horrible op amps. And on the schematic, and this is just a portion of it, this line right here that you see is the bypass line. That there's the relay. This is a relay right here. That's one of the 3 op amps right there. So you can see that it is true physically. You're entirely bypassing those op amps when those tone controls are in the neutral position. That's awesome. That's a must. So, again, yuck. 1000 and 2000, in my opinion, out of the question. And this just answers the same question. Do you have a true tone control bypass? No, you don't in the 1000 and 2000. Yes, you do in the 1100, 2100, and 3000, as long as the tone controls are set to the neutral position. All right. Now we're done with the second part of this. Now let's get into some more nitty-gritty. Where are we at here? Power amp. Okay. All right. So let's talk about something that I don't care much about, but that you guys might care something about, and this is kind of interesting. How and why Yamaha does the things they do. Let's talk about the headphone amps. Now, I know a lot of folks listen to headphones. I know it's a popular thing to do. Sometimes it's a necessity if you have a small apartment or what have you, and people are home and you can't crank up your speakers. So headphone amps are a big thing these days. So let's talk about the differences in the headphone amps between the various designs. Let me just start out with this summary right here, which pretty much says it all. Every one of these models gives you a discrete, not an integrated circuit. Yeah, whoa, sorry. I am wrong about that. This shouldn't say phone, this should say phono. Phono, my apologies. But we are going to talk about the headphone amp because there's no need to talk about the phono amp right now. Every one of them gives you a discrete phono amp, exactly the same circuit, and every one gives you a discrete moving coil, moving magnet, phonograph, record player, turntable, amplifier. They're all the same. Now let's get back to the headphone amps. Okay, now for the headphone amps, and you'll hear me talk here more about evil op amps. Interestingly, the AS1000 gives you an op amp, a real simple op amp design, 10-cent part. That's your headphone amplifier. You jump up to the 2000, you get a discretely designed, better quality headphone amp. Now you move up to the 1100, you're back to the op amp again. So they actually took something out of the 1100. When you move up to the 2100 and the 3000, you're getting their best headphone amplifier. The circuitry is fundamentally different from this one here, from this discrete one. You're getting their best headphone amplifiers, bar none. Fully discrete. Quite complex circuitry too. Not anything simple. So, second. Alright. Let's take a quick look. Alright, so just if you're curious, here is your 1000, and your headphone amp are these ICs right here, and they are operational amplifiers. They're op amps. And that's it. You get an op amp. When you move up to the 2000, you get this. You get a discrete, quite complex circuit for a headphone amp, fully discrete, carefully chosen parts, I'm assuming, and the whole thing. It's a much better quality, much better design headphone amp in the 2000. When you go back to the 1100, boo-hoo, we're back to the same crap op amps for your headphone amplifier. So you'll lose something in the 1100. If you're a headphone person, then the 1100 might not be for you. You might want to spend the extra $1,000 for the 2100. When you go to the 2100, you get an even better headphone amp design. There are differences between this and the 2000. Not worth getting into here, but this is their best design of the family. And it's, in essence, the exact same design in the 3000 for the headphone amp. No difference. Now, I briefly talked before I got on a tangent about the phono amplifiers. Phonograph amplifiers, they're all the same. I mentioned that before. They're identical in all the three amps, and there's the moving coil and the moving magnet, and this is a snippet from the schematics, and they're fully discrete, no integrated circuits. Yamaha was correct about that. Looks like some quality stuff. Alright, now let's get into the final segment of this, where we're going to talk about the signal path from start to finish. And this is really, to me, what it's all about. Is when I say what it's all about, what are the differences between these amps? What am I getting for the price? What are the differences? So let's talk about the signal path from start to finish. And this amp, just like most integrated amps out there, and I printed this this block diagram out from one of the I don't know which model it was, but it doesn't matter. The point behind this is the only point behind this is basically all of these amps have 4 basic stages. Let's just pretend you're plugging your DAC in, okay, or your CD player. They all have 4 basic stages of amplification, where the signal is passed through active devices to amplify either the voltage or the current. First stage is the input buffer. Then comes the volume and tone controls that we just talked about. Then comes basically is a voltage amplifier. They call it a line amp. Okay, and then comes your output. That's your output amplifier section. Your what do they call it? The balanced, floating balanced design. That circlotron amp is right there. Okay, so we have got some voltage gain. There's usually some gain associated with volume controls if they're active, but maybe not, but it doesn't matter. There's some amplification going on here in the form of filters. There's some more voltage gain. Then there's your current gain amplifiers right here. And there's a little bit of voltage gain in this stage too, at the input differential amplifiers. So let's trace the signal path from beginning to end for all of these different models and see what the differences are. Okay, so let's start out with the input buffer. The input buffer is the first thing that your signal is going to see when it enters the amp. And we're not going to get into much detail here. I just want you to visualize that there are differences between these models. And I'm going to have to assume that the differences as the models move up in price equate to higher quality components, and there are differences in the transistors they selected and the capacitors. So let's look at the 1000 and the 2000. Both of these amps, the input buffer is identical. You got some differential amplifiers at the beginning, and then you got your push-pull output stage, and then in the middle you got some voltage gain and some current regulation and that sort of thing, some biasing, standard stuff. There you go. Fully discrete, by the way. Fully discrete, no op amps. Now let's move up to the 1100. Now what you're seeing here, interestingly, is a much simpler amplifier. Operationally, much simpler. The transistors, the input transistors they've selected are field effect transistors as opposed to bipolar junction. So they're moving up in the transistor selection. I'm sure they're more expensive. But it's it's still got a differential amplifier, some voltage gain, and then you got your push-pull outputs right there. So there's your 1100. Now let's go to the 2100. Now the only reason why you're seeing these are two of the same amplifiers. The only reason why you're seeing two of them is because the 2100 is a balanced design, and in the balanced amplifier you've got 180 degree out of phase signals coming in, and they both pass through the same circuitry, just out of phase. But if I compare this circuit right here with this circuit from the 1100, it's the same. So this is one of the reasons where you can say, well, balanced is a balanced design any better? Well, look, it's going through the same stuff. It's going through the same circuitry. It's just that you have two signals that the main signal is copied 180 degrees out of phase and passed through the amplifier that way instead of in single-ended form. But basically the input buffer is the same for the 1100 and the 2100. 2100 is balanced. 3000, same thing. Okay, now it's basically the same circuit. They've added this business right here in the 3000. I didn't really study what this does. At first I thought it was a current source, but now I look at it a little more detail, and I don't know if it's a voltage regulator or a current. I'm not quite sure. I'd have to study it longer to see what it does, but that's the only difference. The rest of the circuit is the same, even the same selection of transistors, identical. So not much difference in the 3000. So in my chart here, I'm calling the AS1000 and 2000 Design 1, and I'm calling the 1100 through the 3000 Design 2 because it's the same design, with the 3000 having a slight variation. I don't know what the hell it does. I'd have to study it and figure it out, and I didn't have time for that. So different designs between these two families, between these two sets of the input buffer. Alright, so now let's go to, we already talked about the tone control, so I'm not going to revisit that. We know that with the AS1100 on up, you can fully bypass this colossal mess, which I do. I don't use tone controls, so that's irrelevant. If you were to own a 1000 or 2000, you're stuck with this. You're stuck with this garbage. Never going to leave you. So let's forget about that. We talked about that. Let's move up to the line amp, which is a voltage gain amplifier, and let's see if there are any differences between these models. Okay. All right, line amps. So let's start out with the 1000. Pardon me. It's my first big sinusy of the day. Well, if this looks familiar to what I showed you as the buffer amplifier before, it should, because it's pretty much the same thing. So the buffer amplifier I showed you before and the line amplifiers are the same circuit in the 1000, almost the same. Now the 2000 buffer amplifier is a little different. It becomes, for some reason, a little simpler, but it's still nevertheless differential amplifier followed by voltage gain followed by push-pull outputs. Classic configuration, but it's different than the 1000. When we bump up to the 1100, we get back to jumping to field effect transistors for the differential amplifier and that much simpler design. And once again, the 1100 is the same as the 2100. 2100, there's two of them because you got your you got your balanced inputs. And just like before, the 3000 is the same except for these little doohickeys up here, and I don't know what they do. I think they're a form of current regulation or some kind of voltage regulation. I'm not quite sure, but in essence the same design. So looking at, we already covered tone controls, looking at our line amp. So the A-S1000, you get a first design, kind of complicated. With the A-S2000, you get a different design. And with the A-S1100 on up, you get basically a third design with a slight variation in the 3000. So again, our 1100, 2100, and 3000 are almost identical. And we're almost finished here. Let's take a brief look now. We've worked our way through the circuit from input buffer, tone controls, line amp. Let's look at the output amplifier, the power amp, the current amplifier stage, the final stage, the floating balanced stage. And we kind of hinted at this before, but you have this floating balance configuration. There's no need to study the crap out of this or what it looks like. I'm just going to say basically you've got some differential amplifiers, a couple more. You've got some drivers. There's same on this side, there's symmetrical. And you've got your three paralleled output bipolar junction transistors in your 1000 and your 2000. The 2000 uses different transistors, but it's the same configuration. They're BJTs, okay? Look at this. When you bump up to the 1000, 2100, and 3000, they are identical. There is no difference in the output sections. Same transistors, same output transistors, same configuration, same diff amps, same everything. So you're not getting anything else in the 3000 that you wouldn't be getting in the 1100 or the 2100. So, and this concludes it. I'll just show you the final summary here. Okay, so for the AS1000 and 2000, you got a first design, basically bipolar junctions, paralleled, and then for the AS1100, 2100, and 3000, you get the same design that uses MOSFETs for the output section. So here was my conclusion. Now again, as you go through this, you might have different considerations based on whether you listen to headphones. If you do, you want a discrete headphone amp. The 1100 might not be good for you. But all in all, the 1000 and 2000 are just out of the question because of those op amps. I don't consider that to be true hi-fi, at least in this application. So the 1100, 2100, and 3000 are almost the same with respect to the signal path with minimal variations. They also use the same power supply caps. So what are you really getting here? Well, the 1100 I feel is the best value price-wise for $2,500, right? The biggest negative I can find is it does use an op amp as the headphone amplifier. I don't give a rat's tail, but some people might if they're really into headphones. So, moving up to the 2100 at $1,000 more, you get all, of course, the positives. It's still a good value. You get one pair of balanced inputs. If you really love balanced inputs, I would use them if I had them. I wouldn't go out of my way to buy them. I wouldn't spend $1,000 to get balanced inputs because, as I mentioned, the signal path still goes through the same amplifier circuitry. Okay, but you do get a discrete headphone amp instead of an op amp. So is this worth $1,000 to me? No, it's not. Now let's jump up to $7,000. What are we really getting for that? Well, yeah, you're getting, okay, so you're getting the discrete headphone amp. You're getting 2 sets of balanced inputs. You're getting a larger VU meter, and you're getting a toroidal transformer. All of that stuff, I don't know, to me, just using my knowledge of electronics and my history in electronics, all of that stuff would, you know, in terms of parts value to make that happen might cost $100, $200 maybe. But to jump from $3,500 to $7,000 to get this stuff is a terrible value. When you look back here and you're getting the same, basically the same power amplifier. Circuitry from beginning to end, almost identical. So my conclusion here is if I had it to do again, knowing what I know now, I would get either the 1100 or the 2100. I would avoid the 1000 and 2000 like the plague. The 3000, even if I had the money, I wouldn't buy it because I'd feel like I'd be getting hosed big time. I would, for the 3000, I would say 4,500, another $1,000 up might be a value, but not $7,000. That's ridiculous. Knowing what we know here, I would probably, if I had it to do again, I'd probably go ahead and make that leap to the 2100, because if I ever do want to listen to headphones, and I might someday, I'd rather have that discrete headphone amp built in. And I wouldn't mind having that balanced input because my DAC provides balanced outputs, and you know, the only advantage you get out of balanced is reduced noise. Is that really an advantage? Okay, is that really an advantage? I can't hear crap. When I turn my 1100 on, regardless of where that volume knob is, I hear no noise whatsoever. The whole point behind this balanced amplifier floating from ground design is it's low noise to begin with. So, you know, I don't know, is it worth it? I'd probably do it just for peace of mind, or maybe the psychological advantage of having balanced inputs, but I know logically it doesn't amount to a hill of beans unless you have extremely long runs. If I was running a signal cable 12 to 15 feet between my DAC, I don't know why that would happen, between my DAC and my amp, I would want to use balance for damn sure. It's the same reason they use balanced stuff in studios and in professional gear, because they have long runs that are exposed to in noisy environments with RF noise and all kinds of stuff. But to run a signal 3-4 feet using balance cable, I think, yeah, I would do it if I had it, but I'm not losing sleep. Alright, so there you go. Did this video to answer questions, many questions that I've received about the 1100 and the differences in the family of amps. I think I've more than answered the question and given you the knowledge you need to make up your own mind. If you're wealthy enough to afford the 3000, well, if I was, you know, extraordinarily wealthy, yeah, I would get it. So who cares, right? Who cares? You know, multi-billionaire, who cares? Get the best. But for those average folks, if you have to go out of your way to leverage and mortgage and borrow, no friggin' way 3000's even close to being worth it. 1100 or 2100. Those are the two to go for. I hope this helps. I hope you found it interesting. It reinforced my decision to buy the 1100. I'm sure glad I did. Those VU meters sucked me in, and little did I know those VU meters had a lot of good stuff behind them. Anyway, thanks for watching, and say hi. Drop by and say hi. Give me a thumbs up. This took a long time to do this research to make this video, so hope it was helpful and enjoyable, and along the way educational. Ciao.